Hi, I'm John Treese with Atlantic Automotive Engineering, a CRP Industries company. Atlantic Automotive Engineering has been around for 28 years. We're a hydraulic remanufacturer of power steering products, specializing on the import side of the industry. And today we're here to talk about the evolution that's occurring in our market segment as vehicles are now transferring from a hydraulic steering system to an electric power steering system. And we're proud to say that Atlantic Automotive Engineering is on the leading edge of that transformation that is occurring. And we're here to introduce our new EHPS Tech Diagnostic Vehicle Simulator. This is Tommy Rutherford, our Director of Product R&D and Research and Process Innovation. And we're going to demonstrate for you just exactly how EHPS Tech works and how that's going to be used in our remanufacturing operation for being able to diagnostically test as well as ultimately remanufacture electronic power steering products. Tommy, why don't you give us a good example of how this works?
This is the EHPS Tech. This is the actual, you have to look at it as the actual car that's communicating with the part. We have a variety of different applications. This one in particular is the Golf 5. So I'm going to demonstrate how we're able to diagnose and communicate with the actual part. Here, as you can see, we have a list of a variety of different applications. We're going to start with the Golf 5. As you can see here, we have power supply, ignition, and external diagnostics. Here we're going to turn on power supply. We're going to emulate a cycle in ignition. And now you can see, we can see dialogue, which is communication from the EHPS Tech to the actual part. You can see that where it has been made previous repairs because they're in yellow for the bus error and the torque sensor. Yellow is okay, so we'll end up deleting errors. How do you know that if they are real errors? The real errors will be highlighted in red, so I'm going to actually emulate that by disconnecting the torque sensor from the ECU. You can see also here it says error, and also has errors torque sensor there that is highlighted in red. After repairs have been made, we're able to go back in, diagnostically check the rack. You'll see the errors have turned yellow. Now we're able to delete those errors, and now we have a functional, working selling unit that we can release to the market.
In the remanufacturing process, the first step is doing the diagnostic testing, because diagnostic testing starts to lead you down the path of what isn't functioning properly with the part and what ultimately will have to be repaired. EHPS products are completely different than the hydraulic parts. They're communicating with the central computer system on the vehicle, and they're becoming much more sophisticated. As people have heard of the autonomous vehicle, electronic power steering makes that possible. Without electronic power steering, you can't have such things as autonomous vehicles. So it is the wave of the future. By 2016, all 4-cylinder, 6-cylinder vehicles on a global platform coming off the production line at the OEM side will all have some form of an electronic power steering system. So this is absolutely on the cutting edge of where the future is going in our product segment.
There's a couple other features that we have here as, as we're in zero speed or where you need to parallel park or something in that case, you need extra power assist. But when you're driving at higher speeds, you're able to emulate those higher speeds and you don't have that power assist that you would normally do when you're parallel parking. So the steering will be a little bit more tighter. As you can see, we also have a torque steering wheel. We're able to measure the Newton meters of torque and also have the amperage current that's coming off of the electrical motor.
If you have high amperage or low amperage, it's an indication of something else on the vehicle is not properly functioning. Maybe you have a dying battery or some other system is causing that. And amperage in an electrical system is one of those key measurement elements that is a good indicator as to what's going on.
Another feature that we have is internal and external diagnostics. So you can run internal diagnostics, or if you prefer to use an external diagnostics, whether it's a Rostec, a Texa, or a Snap-on tool of that sort. Another feature that we have here is electrical connection. So if you do not have the OE plug that will connect to the rack, steering column, or hybrid pump, we show the electrical connection that will actually show you negative, positive, can high, can low, and ignition key. So we have generic pins where you're able to connect to those pins and able to test the unit by this diagram.
So what we have here is the Mini Cooper EHPS, that stands for Electronic Hydraulic Power Steering Pump. This is a hybrid system. So the actual steering system on the vehicle is a hydraulic system, but it's being pressurized with an electric pump versus a traditional pulley-driven power steering pump. And inside of this component here, you have the communication cookie. So inside of here is actually like the inside of a cell phone. So it's a completely electronic part that is being controlled by the vehicle, and it's being communicated with to tell it when power assist is needed. So it's a run on demand versus a constantly running power steering pump. With our EPS tech, we're able to diagnostically test the Mini Cooper pump and to determine if it's functioning properly or not. And with an EHPS unit, you also need a pump drive system because you're testing not only the electronic communications, but you also have to test the pressurization and the hydraulic side of the system. So our system here is able to do both simultaneously. So it's making sure the electronic communication is occurring and those algorithms are running properly. At the same time, we're able to simulate the pressurization of the pump and send it signals to say I need more assist or less assist. So Tommy, why don't you explain what's happening with the system?
Right now it's running into different cycles. You can run typically 5 cycles. You have a load time and you have a rest time, and you have the cycle ignition. So you can basically plug and play, set up, and it'll automatically test the pump. You don't have to be standing over it and watching it or anything like that. You can multitask with it by repairing another unit or setting up to test another unit. This one in this particular case runs on separate diagnostics. We are running with the Texa. And with the Texa, we are able to check parameters based on current, voltage. We also can check for faulty codes for ECU. And also activations. We could run the pump at 100% or we could run it at 50% to be able to check the amperage on it. With the Mini Cooper, you want to be sure that you have the same amperage output as you do the bar and flow reading.
And on the pump drive, we're measuring flow and we're measuring pressurization. So those are 2 critical elements of the hydraulic side of the EHPS unit. If you don't have good flow, that means that there could be possibly a restriction in the system. So without good flow, if someone goes to make a turn, it's not going to give them that power assist, and they're going to feel it at their steering wheel. With pressurization, you want to make sure that the pressure at a lock position holds and it doesn't bleed down. Otherwise, they lose that power assist turning effort.
Right.
Taking a unit once it's been connected to the machine and processing it both through the simulator as well as through the hydraulic cycle, it's about 6 minutes.
This machine can also test full electric racks, hybrid pumps, and as well as steering columns.
Why don't we grab the steering column and just show that? It's a motorized steering column. And in this type of electronic steering system, you have a linkage between a manual rack and pinion, which is connected to your tires. And the steering column is actually what is providing the electronic assist to the steering effort. And in the base here, you have a torque sensor, and then you basically have a DC motor. And this is the actual EC unit that's connecting with the vehicle. And it's measuring vehicle speed, driver input in terms of what's happening at the steering wheel, as well as the RPMs of the vehicle, and what amount of force is being applied. So which direction the vehicle's wanting to be turned in, and how much effort is being applied to that. And all of that information is being captured electronically and ultimately put through an algorithm that ultimately ends up sending a signal to this unit to say which direction and how quickly do we want to turn the vehicle left or right. That power is generated from the DC motor and ultimately down to the steering linkage, which ultimately will actuate the tires left or right. That's how the system works here.
It's an electric steering column. The ECU and the motor is attached to the actual steering column that's driving a manual rack. Here today we're working with the Nissan Sentra. We're going to add power and turn ignition key on. You can see that it's communicating with dialogue. We have no errors. This unit is error-free. So we can run diagnostics with the Texa for checking for error codes. We can also check the torque and Newton meters. Can we also duplicate the different speeds that apply? You can see for vehicle speeds is also communicating with the Texa. And you can really feel the power that's being released from the torque. So as I apply very little torque at the top of the steering wheel, it's producing a lot of significant force down to the manual rack.
So the EPS Tech diagnostic testing system is capable of not only doing the EPS rack and pinion, it's capable of doing your steering columns, and it's also capable of doing your EHPS power steering pumps. So all three elements of the evolving EPS market can be diagnostically tested by EPS. With the new EPS steering, it's obviously a safety element. So making sure that you have the proper calibrations, making sure that you're set to center position, and that all systems are functioning properly is an extremely important element. And through EPS Tech, we can ensure that all those items are addressed and are corrected, so that the unit that we're putting back out into the marketplace with a consumer is completely functioning properly and is up to compliance with all safety standards.